Hello, this is part 2 of the Go programming tutorial. Last time in part 1 we covered a non-preemptive Go programming problem. Now we're gonna be talking about a preemptive Go programming problem. The problems are actually quite similar. I wanted to choose a similar problem and a relatively easy problem so that formulation wouldn't be an issue here, because we mainly want to focus on the technique of Go programming. Okay, so the main difference between the problem in part 1 and this one is that here we are given a priority set, actually two of them, so that goal 2 is much more important than goal 4. Goal 4 is much more important than goal 1, and goal 1 is much more important than goal 3. And this is what makes it a preemptive Go programming problem. What it actually means is that one goal dominates, one or more goals dominate the other goals in terms of priority. We don't have that in non-preemptive Go programming. Okay, let's get to the example. An IT company must determine which of 7 research and development projects to undertake. For each project, 4 quantities are of interest: the net present value in millions of dollars, the annual growth rate, the probability that the project will succeed, and the cost in millions of dollars. The relevant information are given in this table, and the company has set the following 4 goals. Goal 1, the total NPV of all chosen projects should be at least 200 million. The average probability of success is 75%. The average growth rate has to be at least 15%, and finally the total cost of the chosen projects should be at most 1 billion. Okay, this shouldn't be a problem. We've done a fair amount of problems that are similar to this one. So the decision variables are going to be binary, 1 if the project is chosen and 0 otherwise. We define our parameters, and we of course define the deviation variables, uj and ej. uj is the shortage, or the amount by which the left hand side falls short of the right hand side value, and ej is the amount by which the left hand side exceeds the right hand side value. So we get right into formulating the goals or the soft constraints. I don't think that there is anything complicated about them, so here they are. And of course we shouldn't forget to state that the decision variables are binary and that deviation variables are non-negative. Okay, so we are asked in the problem to, or we are not asked, but we are supposed to solve this problem. Okay, so this is a preemptive Go programming problem. So there are 2 ways to solve it using Go. First method is the sequential method, and the second is called the streamlined or the one-shot method. They actually both lead to the same results, but they are quite different in practice. Okay, so if you look at this Go code, I defined the set, the data as usual, and I coded the goals as they are in the file, in the formulation file. And now to the objective function. This is the tricky part, and this is our first priority set. So we're gonna start by implementing the sequential method, which entails solving several linear programs, not only one. We start by minimizing the deviation variable of the goal we prioritize the most, and solve the linear program. The result we get must be fixed in the model and treated as a hard constraint. Okay, let's actually do that so you could see what I mean. Okay, so here in this priority set, the second goal has the top priority. It is the most important one. So this goal has the deviational variables E2 and U2. This is the probability of success goal. So we probably want to we want to minimize the shortage. We want the projects we select to be successful, so you want to minimize the shortage, which is U2. So U2, we can just comment out the other goals. We don't need them. They're just it makes it less efficient to solve the problems while having the other goals. They're irrelevant here. Okay, so we solve the problem. As you can see, U2 is 0 here. So we have the probability of success goal completely satisfied. So we add the hard constraint U2 equal to 0. Next most important goal is goal 4. So we're going to remove the comment and get it back to its initial state, being a goal. Okay, so this is the cost goal. So we want to minimize the excess of cost. We can't possibly minimize the shortage. We want it to be 1,000 or less. Okay, so we minimize, the new objective function is minimize E4. We solve the problem again. So it's a very small number, so we can consider it to be 0. It's even stated that it is 0 here. So we add another hard constraint, E4 equal to 0. Next most important goal is goal 1, so we uncomment it. It's an NPV goal, so we want to minimize the shortage. So the new objective function is U1. We solve it again. U1 is 5. Okay, so again, hard constraint U1 equal to 5. And we are left with the least prioritized goal, goal 3, I mean. And the last step of the sequential method is to put U3, yes, the shortage, to minimize U3. Since it's a growth probability goal. Okay, so we put U3. We have our other deviation variables of interest fixed in here, and we solve the problem. So U3 is 0. And that's how we get our final decision. If we can go to the interface, we can see that projects 3, 4, and 7 are selected. And here are the values of the 4 criteria and their deviations from the goal. For the MPV, we fell under our goal by 5 millions, so it's not too bad, but it's not exactly on goal. The success of probability, we have overachieved this goal. We wanted it to be, actually seems like we underachieved. Okay, so we actually underachieved the success of probability goal. We have overachieved the growth rate goal, and for the cost, we have fallen short of our budget by 40 million. 40 million. It was we had a goal of not exceeding the 1 billion, and we have spent 960 million. Okay, so this was the sequential method, and the other method is called the streamlined or the one-shot method, and here's how we implement it. Okay, so for the goals, we basically do the exact same thing. However, for the objective function, instead of minimizing the deviation variables one at a time according to priority, we're just going to put weights for the deviation variables, since goal 2 is much more important than goal 4, and 4 is much more important than 1, and 1 is much more important than 3. I have multiplied U2 by 1 billion, E4 by 1 million, U1 by 1,000, and U3 by 1. We solve the problem and we get the exact same result. So the projects chosen are 3, 4, and 7. And the deviations are the same. So that's it. We have seen the streamlined method and the sequential method to solve preemptive goal programming. I've talked about the difference between the preemptive and the non-preemptive goal programs, but if you still have questions about that, please do ask about them, because it's important to understand the difference. Let me know if you have any other questions or if anything is unclear, and thank you very much for listening.